Hello! Over a year ago, I made this video about torque wrench extensions. People roasted me over ideas presented there. They were right. Torque is cheap. So in this video, I put to the test what I said in this previous video. Here I have a digital torque adapter, which can work as a torque wrench when used with a regular wrench or a breaker bar. It shows then the torque value in real time. It can be preset to a desired torque value and will give audible signal when the torque is reached. It can also act as a torque wrench tester. In this mode, it will hold the highest value of the torque readout when the torque wrench clicks. Accuracy of this thing is plus minus 1%. And the range goes from 30 to 150 foot-pounds, or 41 to 203 Newton-meters. In this video, I will also use my 15 years old Craftsman torque wrench, made in USA, with range between 20 to 150 foot-pounds, or 33.9 to 210.1 Newton-meters. Turning this ring releases adjustment handle mechanism. And turning the handle, desired torque value can be set. The second is this brand new EPAuto torque wrench that can be set from 10 to 150 foot-pounds, or 13.6 to 203.5 Newton-meters. Small knob at the bottom locks handle at desired torque setting. Another one I have, the oldest one, works from 3.61 to 30.61 Newton-meters. The locking mechanism is released by pulling down this ring, and as in all those wrenches, turning the handle sets the torque value the wrench will click at. The range of this last one is not compatible with the range of the digital tester, so it will not be used in this experiment. All testing will be done at 40 foot-pounds, and it doesn't matter foot-pounds or Newton-meters. What being tested here is the difference between the digital adapter readout and the torque wrench set value. First, I will check how accurate those tools are. The EPAuto is set to 40 foot-pounds. This wrench accuracy is plus minus 4%. Plus 1% tester accuracy, and readings between 38 and 42 will be within specs. $37.7, too low. 37.8, still too low. 37.5, not good. 37.3, new wrench. 38, finally acceptable value. 39.9, oh, it's warming up. 38.7, good enough. 39.6, not bad. 38.3 and 38.9. 4 out of 10 readings were not within the range. The Craftsman. 4% accuracy plus 1%. Again, anything between 38 and 42 is good value. 40.4. Sweet. 39.7. 40.1. Good. 39.8. 40.5. 39.9. 40.4. 40.5. 40.1. 38.9. Is this thing good or what? Now I will grab the handle closer to the nut. 45.1. So it looks that where you hold the wrench matters. Going back to the EPAuto wrench. Set at 40. Clicks at 38.5 when held by the handle. Grabbing the wrench closer to the nut, and it clicks at 47.5. The first lesson learned. Operate torque wrenches holding handles and pulling perpendicular to the wrench arm. Okay, but how can I tell that the tester I use is accurate? I will test it now. The adapter is set in a vise. On the wrench, I mark the distance of 12 inches or 1 foot from the head center. A loop with threaded bolt set to the chain and chain fixed to my press drill column. A luggage scale. The producer claims accuracy of 10 grams at 18 kilograms, which is 40 pounds. Not bad. The wrench is sitting in the adapter. The scale is pulling the handle at 12 inches point. When I turn the nut on the loop bolt, force is applied to the wrench handle. And here we have the real-time readout. By the way, the force must be applied perpendicular to the wrench arm. The scale, the adapter, and the Craftsman wrench agree with each other to a certain degree within accuracy. Therefore, before other tests, I will calibrate the new EPAuto wrench. When any torque wrench is calibrated, it should be done in the middle range of the wrench. In this case, I will calibrate it at 80 foot-pounds. Within ±5% accuracy, I should get readings between 76 and 84. 74.6. Too low. $74.4. Not good. $74.7. $74.8. 75. 74.7. How to calibrate this wrench? By loosening the lock knob and setting the wrench to the lowest torque value. Now the big nut has to be undone, holding the handle. The threaded insert must be turned clockwise to increase the torque and counterclockwise to lower it. The big nut goes back in. Tightened. And testing new setting. 80 foot-pounds set on the wrench. And it clicks. 78. 77. 78. I will adjust it more. And now 82.9, 81.9, 82.1. Not bad, but I will tune it even more. 80.2, 79.8, 80, 79.4, 80.1. Beauty. The Craftsman, set to 80 foot-pounds. 79.4, 80.2. Holding close to the nut, 87.2. 86.0. The torque value delivered definitely increases when the force is applied closer to the nut and not at the handle. The EPAuto wrench set to 80 foot-pounds. 79.2. And 80.2 when held by the handle. When held closer to the nut, it delivers 88.2 foot-pound torque force. How to calibrate this kind of wrench? Obviously, I will not calibrate this Craftsman, but if needed, I would remove this plug, set the wrench to the minimum setting, loosen this big nut inside, and turn with this Allen key the middle bolt, turning right to increase the torque, left to decrease. This one, same story. Plug, nut, bolt. Another test. The torque wrench set to 40 foot-pounds. Extension at the axis of rotation. 41.6. 41.4. 41.6. 41.5. 41.7. Longer extension at the axis of rotation. 41.2. 42.5. 42.3. Even longer extension. 41.1. 41.7. 41.6. 41.7. And once again, no extension. 41.4. 41.8. The second lesson learned. The extension in the axis of rotation of the nut does not change the torque applied to the nut. Sometimes the nut that we must tighten to a specific torque value is accessible only one way. It does not reach the nut at 90 degrees. What is the difference when the extension is applied straight and when at the angle? To examine this, I made such an extension. It is not a beauty contest, it is an experiment in physics. Extensions designed for this purpose can be purchased on the market. Links in the description. The wrench set to 40 foot-pounds. No extension, it presses 41.5. 40.5. 41.3. 41.6. The extension set at 90 degrees to the wrench arm. $41.7. 41.4. 41.2. 41.1. The extension set forward along with the wrench arm. 49.6. 50.2. 50.7. 51. Back to 90 degrees. I am trying to do 90 degrees as close as possible. $40.7. 41.9. 40.7. 41.2. And now the extension set backwards along with the wrench arm. $33.7. 33.6. 33.5. The third lesson learned. Setting the extension at 90 degrees to the wrench arm does not change the torque value set on the wrench. Extending the wrench arm increases the torque. and shortening the arm lowers the torque. The extension is 3 3/4, and the torque value delivered can be calculated using formula supplied by the manufacturer. The extension can be used to apply specific torque to a flare nut, or it can be used to extend the torque range scale. But this is subject to another video. Until next time.